Today we will talk about basic hypothesis testing. Now the first thing we need to remember that using the traditional method, we reject the H-null if the calculated statistic falls within the critical region. And we fail to reject the H-null if the test statistic does not fall within the critical region. Where do we know where the critical region goes? That's from the confidence intervals and from the tables. Now, when we do the same thing, the hypothesis testing using the p-value method, we will reject the H-null if the p-value is less than or equal to alpha. Alpha is the significance level. And then we fail to reject H-null if the p-value is greater than alpha. So let me show you an example. If we are doing hypothesis testing for proportions, this is the formula, this is the test statistic formula that I need to use. For example, if we have an article distributed by the Associated Press included these results from a nationwide survey, and we have 880 randomly selected drivers, 56% admitted that they run red lights. The question is, test the claim that the majority of all Americans run red lights at 95% confidence level. We first need to check NP and NQ greater than 5, and that satisfies. And we set our H-null and H1. Since it says majority of all Americans, we pick P greater than 0.5, more than 50%. That's our claim. And we are doing this at alpha of 0.05, which is 1 minus 0.95 here. If we were to do this problem calculating the Z, this is the formula we would have used. And this one is given. And this one is that number that we get from the H-null. And now we can calculate P, Q, and N. And N is given 880. We get 3.56. We compare 3.56 to Z critical. And it's a right tail test. The Z critical is 1.645. Now where's the 3.56? It's around here. And 1.645 is around here. So what happens? We are inside the critical region. We reject H-null. Reject H-null. That means the claim is good. How do we word that? There is sufficient evidence to support the claim. Now, if I were to use the TI-83 or 84, I go to Stat, and I go to Test. And here I pick one prop Z test. And I have to enter the P0. P0 is this value, 0.5. X is 493. And this is pretty much 0.56 times 880, 493 right here. And it's 880. And this line will tell me what I'm doing with my H1. It's greater than, so I have to pick this portion, greater than. To pick it, you push enter, go down, calculate. That gives you a P of 0.000176, which is less than 0.05. That tells me I'm in the critical region. That means I reject H-null. Now let's go to the next case. Let's assume I'm doing hypothesis testing for a mean and my population is normally distributed and my sample size is greater than 30. This is the test statistic I need to use. Now let's go to an example. A sample of 106 body temperatures has a mean of 98.2 Fahrenheit. Assume that the sample is a simple random sample. And the population standard deviation is known. So let's go back. You have to make sure that sigma is known to be able to use the test statistic. Let me go back and put an equal sign in here. Alright. Now, if I were to do this by hand, I put H null and H1. And this one is mu is 98.6, which is my claim, and mu is not 98.6. When I calculate my Z, you just put the 98.6 right here, and this is your sample mean, and you get negative 6.64. Since it's not equal, it's a two-tailed statistic. And where is your Z critical? This is obtained from the tables or inverse norm from your calculator. It's negative 1.96 or positive 1.96. And since I'm in negative 6, I'm around here. That means I am in the critical zone. We reject H null. Let's do the same problem using the calculator. I go to Stat, and we go to Test. And this time we are going to do the Z-test. What do you enter? Statistics. This one is your mu, which is this one, 98.6. And this is your standard deviation of 0.62 right here. And your sample mean, which is 98.2. Let me enter that, 98.2. And your sample size is going to be 106. And how am I going to pick this line? I have to look at H1, not equal, so it's going to be this one. And when you go down, calculate. Actually gives you the Z, which is the same as this value. But what you can do is just compare the P. P is very small. That means P is less than alpha. Alpha is 0.05. Therefore, you're in the critical zone. Therefore, we reject H null. Therefore, there's sufficient evidence to conclude that the mean body temperature of healthy adults differs from 98.6, which is this statement here. Now, let's go see a hypothesis testing. Let me clear this. For mean, again, this time, sigma is not known. I'm missing an equal sign here. So this is the formula you need to use. Let's go to the example right away. A pre-med student in a statistics class is required to do a class project. She plans to collect her own sample data to test the claim that the mean body temperature is less than 98.6. At this point, I put that in the H1 with the claim notation right here. The opposite is going to be mu greater than or equal to 98.6. She goes and measures body temperatures and obtains this data from 12 people, n equals 12. The sample mean is 98.39 and the standard deviation 0.535. Now this is sample standard deviation because I do not know the population standard deviation. So I need to do this at 95% level. I go calculate T, plug in all these numbers, and I get negative 1.36. How do you compare this? You don't go and compare it to the alpha over 2. You have to go and get the T critical from your tables when you do it this way, with a degree of freedom of 1 less than your sample size, which is 12. Or you can go and do it with your calculator. Let me show you how to do that. You go to Stat, Test. This time I'm going to go to T-test. I'm doing statistics. And this is the value that you enter in here, 98.6. And what is the sample mean that she got? This is 98.39. So let me go enter that. And the sample standard deviation is right here, 0.535. And my sample size, we're talking about 12. And I'm looking at H1, that's less than, so I have to go get this value. And I'll push calculate. When you do that, when you get a p-value of 0.1, 0.1, and that's greater than 0.05, so that means I'm outside the critical region. That means I failed to reject H null. I failed to reject H null. So that means this is not good. How do I say that? There is not sufficient evidence to support the claim that the sample comes from a population with a mean less than 98.6. And this concludes the portion about hypothesis testing using your TI-83 or 84.